In section 10.3, we move from two independent samples with testing the population means to now we're going to be testing the population proportions. So for our sampling distribution of the difference between two proportions with independent samples, suppose that a simple random sample of size n1 is taken from a population where x1 of the individuals have a specified characteristic, and a simple random sample of n2 is independently taken from a different population where x2 of the individuals have a specified characteristic. So we are testing the same characteristic in both of these, from both of these populations. The sampling distribution of p hat 1 minus p hat 2, where p hat 1 is the sample proportion of the first sample, and p hat 2 is the sample proportion of the second sample, is approximately normal with mean mu sub that p1 minus p hat 1 minus p hat 2 is p1 minus p2, and the standard deviation is given there with a very complicated radical formula, provided that, again, our sample is large enough, which means n1 times p hat times 1 minus p hat is greater than or equal to 10, and also n2 times p hat times 1 minus p hat is greater than or equal to 10. Now, don't get scared about all this notation. Again, we're going to be using the calculators to help us, and it's just a matter of typing in the stuff. The calculator will do all of this work for us in the background, but these are the formulas that the calculator is using. Once again, we do want to make sure the sample size is no more than 5% of the population size. The standardized version of our P1 hat minus P2 hat is written as this. The z-score would be given here, and with proportions, remember we do use z-scores, but again, we don't have to worry about this. The calculator will take care of this formula for us, and this would give us the approximately standard normal distribution. Note, the best point estimate of P is called the pooled estimate of P, denoted by P hat. So that's from both groups. And notice what you're going to do there. You're going to add the the individuals with the characteristic from the first sample plus the individuals with the characteristic from the second sample. And then we're going to divide by the sample size from the first group and the sample size from the second group. So we're putting them all together. The test statistic for comparing the two population proportions is given here. And again, we don't really need to worry about these, but these are the formulas that are going on in the background of our calculator's workings. To test the hypotheses regarding two population proportions, P1 and P2, we can use the steps given below, provided that, again, the samples are independently obtained using simple random sampling, and that for both of our samples, the sample size times the proportion, sample proportion, times 1 minus the sample proportion is greater than or equal to 10. We also need to make sure that the sample size is less than 5% of the population size for both of these samples. So first, again, we will determine the null and alternative hypotheses, just like we've done previously. Then, step 2, we will determine the type of test and draw a figure representing the type of test. Again, that's not super important for us since we're not basing it on the critical values, but we're using the p-values instead. Number 3, select a level of significance, alpha, based on the seriousness of making that type 1 error. And if alpha is not provided, we will assume it's 0.05. The p-value approach is the one that we will use. Part A, compute the p-value from the two proportion z-test. So again, two proportions because we're dealing with two samples. B, compare the p-value to alpha. And as previously, if the p-value is less than alpha, we will reject the null hypothesis, and there is enough evidence to support H sub 1, and the result is statistically significant. If the p-value is greater than alpha, we will fail to reject the null hypothesis, and there is not enough evidence to support the alternative hypothesis. Then we make our conclusion regarding the claim and interpret it in context of the scenario. On our calculators, this is how we will have the calculator do all that complicated math for us. We will press Stat, we will highlight Tests, and we will select number 6, the two proportion z-test. Second, we will enter the values of x1, n1, x2, and n2. That's the only 4 values that we need from the problem. Then number 3, highlight the appropriate relationship between P1 and P2 in the alternative hypothesis. Highlight, calculate, or draw, and press enter using calculate. Remember, gives us the test statistic and the p-value, but using draw will draw the z-distribution with the p-value shaded. We're not going to use the draw method. We're going to stick with the calculate method so that it's always kind of the same thing that we're doing. Example 10.4, an economist believes that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. The economist obtains a random sample of 800 urban households and finds that 338 of them have internet access. The economist obtains a random sample of 750 rural households and finds that 292 of them have internet access. Test the economist's claim at the 0.05 level of significance. So let's go to our next slide so we have some space to do this work. Now the first thing I'm going to do is test to see whether we have large enough sample sizes. I would think with 800 and 750 sample sizes we would have plenty, but let's just double check it. So we're going to have n sub 1 times p sub 1, which is 338 over 800, and then 1 minus that 338 over 800, and we're going to multiply that out. And we want that to be greater than or equal to 10, so let's just double check. 800 parentheses 338 divided by 800, close our parentheses, and then parentheses 1 minus 338 over 800. And as I guessed, it is much higher than 10, so we're good there. And then we're going to do the same thing, but we'll replace this with the smaller sample size of 750 times 292 divided by 750, and then parentheses 1 minus 292 divided by 750. And again, this is kind of a technicality with sample sizes that high, but just to double check, and we get 178. So we're good. We know that our samples are large enough. And also, we know that they should be less than 5% of the population because there's a lot more than 800 households in urban areas in the United States, and that can't be 5%. There's a lot more. The 750 can't be 5% of all the rural households in the United States, so we're good there as well. But let's write down our information. Remember what we need. X1 is the group from the first sample, 338 that have internet access out of the total of 800. Then we needed X2, which was the 292 people who have internet access out of the 750. And then remember that our alpha level is 0.05. So let's go to our calculators. We're going to go to stat, over to tests, and down to number 6, the 2 proportion z test. We select that, and we're going to enter these values. X1, 338. N1, 800. Oh, I just realized I forgot to write down my null hypothesis. Well, we're going to do that in a second. X2, 292. And then N2, 750. Because before we do this one, we've got to write down our null and alternative hypothesis. So null hypothesis is that P1 hat is equal to P2 hat. Remember, there's no difference between them. That's always going to be our null hypothesis, is equality or no difference. Then the alternative hypothesis is from his claim the percentage of urban households is greater than the percentage of rural. So he's saying that P1 hat should be greater than P2 hat. So that's what we're going to select. And actually, it's already selected, but I'm going to go over there and hit enter anyway. And then we calculate, and we get our z-score. Notice that is our test statistic, if any of the questions ask for that. But our p-value is 0.0920 if we round that off. And p, in this case, is greater than alpha. And if p is greater than alpha, we fail to reject the null hypothesis. So that means in our context, when we interpret this, here's what it would mean. There is not enough evidence to support the claim and here's our claim. I'm just gonna, oh, I forgot to mark it. Here was our claim. It's also up here. There is not enough evidence to support the claim that the percentage of urban households is greater than the percentage of rural households when it comes to internet access. Example 10.5, a concerned group of citizens wanted to know if the proportion of forcible rapes in Texas was different in 2011 than 2010. Their research showed that of the 113,231 violent crimes in Texas in 2010, 7,622 of them were forcible rapes. In 2011, 7,439 of them, of the 104,873 violent crimes were in the forcible rape category. Test the group's claim that the proportion of forcible rapes was different at the 2% significance level. Okay, so again, they're looking at the statistics for their entire state. So again, when you look at these, they've got enough values there, 7,000 and, well, actually 104,000, 113,000, those are your values. So there's plenty of sample data there. So let's take a look. Remember that the null hypothesis is that there is no change. So P1 hat will equal P2 hat. And remember that for us, this is going to be 2010, and this is going to be 2011. So then the alternative hypothesis is going to be that P1 hat is different than P2 hat, because that's what they said, it was different, so it's not equal to. Our alpha value is 0.02. Notice X sub 1 is going to be, let's see, the research showed in 2010. So 7622, and N1 is 113231. Then we have X2, and that was 7439. And N2 and N2 was 104,873. So fortunately, both of those things went down in 2011. But anyway, let's take a look. Let's go to stat. Let me erase that check mark. We're going to go over to tests. We're going to select 2 proportion z-test and X1, 7622. N1, 113231. X2, 7439. N2, 104,873. And our P1 is supposed to be not equal to P2 according to the claim. I should put this as the claim, or that's what they're trying to test anyway. So we'll go down to calculate and hit enter. And we find out, again, your z-score is there, but P is equal to 8. Well, it can't be equal to 8, can't be bigger than 1. So again, you've got this times 10 to the negative 4th. That means scientific notation, which means we move the decimal point over 4 spaces. And then we have the 8. So 0.000, it'd actually be a 9 if we round it off there. But still, P is definitely less than alpha this time. And that means we will reject, I don't have space here. Let's reject the null hypothesis. Now, when we interpret that, here's what it says. There is enough evidence to support the claim that, and our claim was that the proportion of forcible rapes was different in 2010 than it was in 2011. And that is the end of section 10.3. So you've got those 3 graded problems to work on. And again, don't hesitate to give me a call or an email. Probably not a call, but give me an email or send me a message on MyOpenMath and let me know if you have any questions as you go through those problems.